value when looking at equations and rates of change. So a linear relation consists of a rate of change, which is slope or unit rate. So lots of different ways that we can say rate of change, and or the initial value, which is the starting value. And we touched a little bit on this in the last lesson. So it's the initial value is basically where your graph starts. So determine the rate of pay for each of the following in order to find the initial value, if any, and then classify each as partial or direct variation. So if you remember from last time, partial variation is when the graph starts somewhere on the y-axis other than at the origin. Direct variation is when the graph goes directly through the origin. So example 1 says Sheridan enrolls in a fitness program. Her total cost is made up of a sign-up fee and a cost per class. So that cost per class would be your rate of change. The sign-up fee would be the initial value. The table below shows information about her total cost C in dollars when she attends classes. So it says to determine the sign-up fee for the program. So there's a couple of ways that we can do this. If you're noticing, this chart here goes up by 2s on this side, and then you can figure out that it goes up by 7s on this side. So this would represent your x-axis, this would represent your y-axis. So what we are trying to find when we're looking at the initial value is we are looking for when the x-axis is 0, what is our y value? So one way to do this is to create your table of values kind of backwards. So I'm going to make a table here to kind of mirror. I don't like the way that looks. I'm going to make the table of values here. So we'll just kind of build off of the one that's already there. So we know down here that this is 12 and this is 14. Center everything for you. Nope. So what we want to do is we want to know when x is 0. So when x is 0, what is this y value? And this is a little frustrating. So we see here that our table goes up by 2, so we're going to go up by 2 as well, just to kind of mimic what's happening in the table. So what would it be if we went back up to where this x value is equal to 0? So we're given these values in this chart, just like we are up here. So we know that this increases by 7. So that means that this number would be decreased by 7 so that we follow that pattern, because we know that it's a linear relation. So if this goes up by 7, well then this one has to go up by 7. So we're going to kind of take away 7 from each number prior to see where we end up. So taking 7 away from the number below. So when we get to 0, when our x value is 0, our y value is 25. So if we were to graph that, I'll just kind of sketch it quickly for you. So if this is our Cartesian plane, we know that this coordinate, or this set of coordinates, when x is 0, y is 25. So we know that that's a point here, and just to show, at 2 we're at 32. So we know that our graph is going to look something like this if we sketch it. So the initial value is the sign-up fee. So when it asks us to look for the initial value, it's asking us to look for what is the actual sign-up fee. So here we can say the initial value or sign-up fee is $25. $25. It also asks us here to decide whether it's partial or direct variation. So we see if we sketch it up here that it's not going directly through the origin down here. So this has to be partial variation. So that's example 1. Example 2, the table shows information about the total cost to rent a car and the distance driven. Determine the fixed fee for renting the car and the cost per kilometer. So fixed fee is another way to say initial value. Where are we starting? So it's asking us to determine the fixed fee for renting the car and the cost per kilometer. So that's a rate of change it's asking us to find. So if we look at this table, we can say that this is our X, this is our Y, kilometers, so cost per kilometer, X values and Y values. We want to know when X is 0, what is our Y value? So we can notice that this table increases by 100 each time, so it's a regular interval that it's increasing. And this one increases by 15 each time. So if we go back for every 100 kilometers driven, the total cost increases $15. So if we go back 15 here, so if we take 15 away from 65, we are going to get 50 here. So that means our initial value, or our fixed cost, our fixed fee, for renting the car is $50. It's also asking us to determine the cost per kilometer. That is the rate of change. So you are going to calculate the rate of change using slope formula. So m equals y2 minus y1 over x2 minus x1. So you're just going to look at your chart and you're going to take a couple points. So I'm going to use this point here and this point here. You can use any points you want. I just think that those ones looked like good ones to me. So my y2, remember your y column is here. My second y point is this 95. So I'm going to have 95 minus my y1, which is 80. Divided by my x2, my second x point, which is 300, minus my x1, which is the top point, which is 200. So if you solve this, cost per kilometer, 95 minus 80, I'll write it up here, is 15. 300 minus 200 is 100. And if you divide 15 by 100, you are going to get 15, or 0.15, 15 cents. So the cost per kilometer is 0.5 dollars. Sorry, The fixed fee for renting the car is $50, so that's what we figured out here, our initial value, fixed fee, initial value. And then the cost per kilometer is a rate of change, so you need to use slope formula to figure that out. So we plugged in these 2 points and figured out that the cost per kilometer is 15 cents. Example number 3. There is a linear relationship between the total cost of renting a costume and the number of hours the costume is rented for. So for 3 hours, the total cost is $60. For 5 hours, the total cost is $80. What type of variation is this relationship? What is the initial value? So we're going to create a table of values again. I need to put my cursor where I want it. All right, so we're going to create our table of values. So which one is the independent variable, which is the dependent variable? So hours, time, is normally on the x-axis. So this is our x-axis, and then our y-axis is cost. So we know that we have to go up to 5 hours. So I am going to just fill it in from 0 to 5. So 0, 1, 2, 3, 4, 5 hours. But I know that the cost at 3 hours is $60 and the cost at 5 hours is $80. So the question is asking us to find what type of variation and the initial value. So what we're going to do is we're going to fill in this table of values based on the information that we're given. So we know for every 1 hour, or for 3 hours, it's $60. 4 hours, we're not quite sure yet, but 5 hours is $80. So what pattern do you see here in the table of values? You should notice that this goes up by 10. So it's at 4 hours, if we were renting the costume, it would be $70. So that means for 2 hours, it would be $50. 1 hour, it would be $40. And for no hours, it would be $30 to rent the costume. So the initial value, remember we talked about initial value being when our x is 0, what is our initial cost? So our initial fee oh my goodness, I am having trouble today. The initial value is $30. So is this partial or direct variation? Again, if we sketch it, so when our x is 0, our y is 30, that should tell you right away we are not at the origin. This is an example of partial variation. And lastly, we'll take a look here at example 4. So example 4 says the total cost of swimming at a community swimming pool is made up of a membership fee. So that membership fee is your initial value or fixed cost, and a cost per swim. So cost per swim should signal to you that that is a rate of change. At this community center, Aiden pays a total of $100 and swims 40 times. Anova pays a total of $70 and swims 25 times. Determine the cost per swim and membership fee. So I will start this question for you. I want you guys to think about it and finish it. I want to see where your thinking is on this question. So the independent variable, which would be on the x-axis, would be number of swims. Oh my goodness. And on your y-axis would be the cost. So we know, I'm going to make this chart a little bigger. So this would be my 25 swims for Avona. And this would be my 40 swims for Aiden. Just going to center this so it's easier to see. And the cost for Anova, I think I said Avona, Anova is 70. And the cost for Aiden is 100. So I left some blanks on purpose. So you guys are to determine the cost per swim and the membership fee. This is asking for the rate of change. So you're going to have to use slope formula with the points that are given. And then I want you guys to try to come up with the cost per swim. So I'm going to leave this with you. Ask any questions if you have any. Thanks, guys.